Hello and welcome to day 5. Day 5 for me, not for you. Today is December 11th, so I am 6 days behind, but I'm going to be putting out 3 videos today, so hopefully I will catch up. Alright, here we go. Day 5. Here we go. Let's start off by pulling in the code. We've got the code. Okay. You board your plane only to discover a new problem. You dropped your boarding pass, not sure which seat is yours, and all the flight attendants are busy with the flood of people that suddenly made it through the passport control. Because we did that on the last day. Yeah. Quick program, binary space partitioning. Okay, so there's probably something easy that we can do with binary processing. Zones or groups. This airline uses binary space processing. Seat might be specified like FB, FB, BF, etc., where F means front, B means back, L means left, R means right. Okay. Start with the whole list of rows. The first letter indicates whether the seat is in the front, 0 through 63, or the back, 64. Okay, so it's essentially binary, right? B keeps rows 44 through yes. The final F keeps the lower, okay? And then we just consider, okay, so that should be like a binary number, actually, if we just convert, if we convert the B's to 1 and the F's to zeros, okay? Characters will be either L or R, which is, it's probably very similar, 0 through 7, yeah, so less than 8, so that's binary. Upper half, okay, so decoding reveals that it's at row 4, column 5, and we multiply by 8. Okay, we actually take the last 3 values here, which are going to equal 5, and the first values, which equal 44, but then we multiply them by 8, which basically means that we just translate this entire thing into binary and then spit out the binary value. Okay. Okay, yeah. Well then, let's do that. That's relatively straightforward. Okay, so let's do this. So we've got our data. We split on new lines. What does this actually look like? I think this is actually what that's supposed to look like. So let's throw this into our input. Okay. Okay, and we will, some other boarding passes. Look through your list of boarding passes. What is the highest seat ID on a boarding pass? So the highest seat ID of these 3 is 820. Okay, so we're shooting for the third one, which is 820. Okay, so we have, well, let's just translate all those values to 1s and 0s, right? L is going to be L is going to be 0, F is going to be 0, right? Left and front, and then back and right are both going to be 1s. So we will do translation is going to be string dot make trans. We're going to have back is going to be 1, right? Right is going to be 1. Oh wait, these should actually be strings because we're translating strings. Left is let's keep the pattern consistent. Front is going to be 0 and back is going to be 0. Okay, and then we will say seat IDs is is, so we've got our data. So we take the integer, right? So we've got all the seat IDs. So we take the integer of line dot, or let's say row, because it's an airplane, row dot translate, translation, and we're going to convert that from binary for row in the data. And we would just return the maximum of that. And if we test this out, invalid literal 0, 0, what did we do wrong? Back, right, front, I said back, left. There we go, 820, which the max that we saw here was 820. Okay, perfect. So let's get the puzzle input. Wow, that is long. We'll input that in there, 780 values, and let's figure out what the 866 is the maximum value. Okay. Bam. Okay. Continue to part 2. Relatively straightforward. Let's hope part 2 is very similar. Fasten seatbelt signs have been turned on. Time to find your seat. It's a completely full flight, so your seat should be the only one missing, which makes sense. Boarding pass, the only missing boarding pass in the list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on the aircraft. Okay, so there are boarding passes that don't exist on. There would be boarding IDs that don't exist on them. So they'll be missing from your list as well. Your seat wasn't at the very front or back though. The seats with IDs +1 and -1 from yours will be in the list. Okay, so basically we're missing a value that is not on the list. So let's take this, right? So we're missing something actually. So let's take the seat IDs again. So we can process our seat IDs. We're gonna do seat IDs dot sort. Sort. We're gonna say for seat in range length seat IDs, and let's start with the with index 1. And we say if seat IDs of so if the difference between the two seat IDs is not 1, right? Where basically each one is going to be numbered, so it's going to have the correct number of seats on the plane. So if seat IDs of 1 does not equal seat IDs of, oh, sorry, not 1, of seat minus 1, wait, seat minus 1 plus 1, so the previous seat plus 1, then we can return seat. Theoretically, right? 499. Let's test this out. Let's see if we got the right answer. Nope, not the right answer. Okay, so we will go back. Okay, so what I was thinking was, in theory, we go through, this is the seat, right? This is going to be seat 1. Seat 1, and then we have seat 2, or seat 0. It compares seat 0. If it doesn't equal seat 0's value plus 1, then that should be the, okay. Let's print off the seat IDs sorted. Okay, so it starts with 84, 85, 86, etc. all the way up. Oh wait, there's actually an easier way to do this. For seat in range, minimum seat IDs, maximum seat IDs. If seat not in seat IDs, return seat. So basically, if we go from the minimum, which is 84, all the way up to the maximum, which is 866, we should find one that's missing in that entire range. Okay, yeah, let's do it. Let's do it that way. 583. Okay, I'm not sure why we got 499 on the last one. Why did we get 499? 499. I don't know why we got 499 on the first one. But I'm pretty sure that 583 is the correct response here. So let's return to day 5. Let's enter 583, just like that. Okay. Relatively straightforward, although I did get it wrong because I'm sure some kind of stupid mistake. But basically, iterate through all of the values in seat IDs, and if it's missing, then that's your seat. There you go. Relatively straightforward. This is kind of fun, just the fact that it's a binary translation. Although it's interesting that they decided that this particular one, it would be multiplied by 8, which basically just makes it a straight binary conversion. You don't actually have to do any, this is not special math right there, right? So just an interesting choice to do it that way, rather than actually forcing you to split those inputs. But there you go. All right. Well, with that, I hope you enjoyed it. I think that's kind of a short one for the day, but day 5, there you go. We've scratched that one off the list, and we're catching up. If you enjoyed the video, please like, share, subscribe, comment down below, telling me how dumb I was on that mistake, and let me know what you think. Until next time, I'll just see you in the next video.